data from the chat log, from the chat sessions. So just so you know, if you're uncomfortable with that, you're free to leave the session. All right, so today's webinar is on analyzing electricity rate structures for distributed generation projects in SAM. And we're going to talk about various elements of a rate structure, so energy and demand charges, time of use, tiered structures. We'll spend a little time talking about net metering, and then we'll talk about the OpenEI utility rate database and a technique for using SAM for value of electricity analysis. I'll be switching between presentation slides and live demonstrations in SAM. And so let me just start with I guess one thing before I continue here is just a few logistical items. For Q&A, I'm going to talk for about 40 or 50 minutes, I think, today. And as I'm speaking, you're welcome to ask questions using the chat window. I'll try to pause and monitor those from time to time. And then at the end of the session, we'll have a Q&A session. And if we can run over a few minutes if we need to, but we'll try to stick to the hour schedule. So here we go. So we're talking about modeling distributed energy systems in SAM. So I thought I'd just give a quick definition of what I mean by that. So we're talking about a building. Could be a residential or a commercial building, and that building has an electric load, which we represent in SAM using inputs on the electric load page. And then the building is connected to the grid, and it can so it purchases electricity from the grid, and then there's some sort of a renewable energy system either on the building or on the facility's property that's generating electricity. Part of that electricity is being used to meet the load, and any excess electricity is being delivered to the grid, and then there's some sort of a financial agreement between the property owner and an electric utility to be compensated for that electricity. So that's basically what a distributed energy system is. And then in SAM, you've got other inputs to model the project finances. But what we're mostly going to be focusing on here is the electric load and the utility rates part of SAM. In SAM, we use one of two financial model options to model a distributed energy system. The residential financial model and the commercial financial model. And in this context, think of residential and commercial in the same way that a real estate agent would. So a residential building, a house, or a commercial building or facility. The two financial models are mathematically identical. There's just a couple of differences in the options for how you model debt and taxes that differentiate the two models. We did a webinar back in 2013 where we talk more about the residential and commercial models. So you can refer to that webinar recording to learn more about those models. To choose the residential and commercial financial model in SAM, for those of you who might be new to SAM, when you first start the model, you see a window that looks like this, and you choose a performance model on the left side here, and then based on the option that you choose, you get a list of options for the financial models that are available for that performance model. So for a PV system using the PV watts model, the residential and commercial models are listed here at the top. So you choose one of those. We're going to be using the residential models for our examples today, but we could show the same things with the commercial model. So the kind of analysis questions that you might be using SAM to answer are things like given a residential system, how much money would the homeowner save on their electricity bill by installing the renewable energy system? Or if you're, a researcher, maybe you're interested in looking at what the value of electricity is that's generated by a renewable energy system. To answer these kind of questions, you need 4 basic pieces of information. You need to know what the building's electric consumption is. So that's the building load. That's an input in SAM. And as you know, SAM is an hourly simulation model. So SAM needs hourly electric load data. That's tricky to find, and we'll talk about that more later. You also need information about the retail electricity rates. So that's generally, the kind of information you'd find on an electric utility's rate sheet. And you need information about net metering rules if you're modeling a system where net metering applies. You need information about the renewable energy system's electrical output. So this is basically the system's hourly output in kilowatt hours, and that data is generated by SAM's performance model. So you set up your PV system or your wind system, set up all the inputs for that, and when you run the model, it generates the hourly generation profile over a single year. And then finally, you need information about the life cycle cost of the renewable energy system. So SAM will calculate that value using the installation and operating costs that you provide as inputs, and also the details of the financial structure for the project. This is a screenshot of the navigation menu in SAM, where you go to the different input pages. So the input pages toward the top are for the performance model. So you need information about the solar resource in this case for a PV system. And you specify the system's design parameters, and then you provide inputs for the financial model, so costs, and then the financing and incentives inputs. The inputs that we're going to be focused on today are the utility rate and electric load inputs. So let me show you what this looks like in SAM. We're going to look at a basic distributed energy project with a flat buy rate, flat sale rate, and no net metering or other complex elements. So just a very simple rate structure, probably not very common, but one that will at least get us familiar with the inputs in SAM. I've got the name of the SAM file down here, so I'm going to save these SAM files that I'm using for the demonstrations and post them on the website. So as you're looking through the presentation, after today, you can open the SAM file and play around with it. All right, so let's see if I can get SAM going here. There we go. All right, so when I start SAM, I see the welcome page here, and I'm going to start a new project. I like to do that by clicking File New, but you can also do Create New File. And I'm going to use a PV system as an example here, but these techniques also work for any distributed generation project. So it could be wind, it could be, a commercial trough system. So don't be turned off by the PV example if you're interested in other technologies. So PV watts residential, and I'm just choosing the PV watts model because it's a simple one, and since I'm not talking too much about the performance side of things, I'll just use the simplest model we have here. And now SAM creates a case for me. So this is our PV system. It's in and again, as you know, when you create a case in SAM, SAM creates a file with all of the inputs populated with values. So this, you click File New, choose your performance and financial model, and you're ready to go. You can click Run without doing anything else. So let's just take a quick look at what the default assumptions are for the system. It's a system in Phoenix, Arizona. It's using a Phoenix TMY3 weather file. It's a 4 kilowatt system. It costs $3.77 per watt to install. Has an operating cost of $20 per kilowatt year. So these are all default values, and in a real analysis, you would be changing these values for your system. This project is financed by 100% loan. We've got some tax assumptions here. There's a 30% federal ITC, 25% state ITC for incentives. And then we get to what we're interested in, which is the utility rate and the electric load page. Let's start with the load. As I mentioned, we need hourly data for the load data, and we have a default load data set for the default system. And if we click Visualize Load Data, we can see a picture of it. Click Energy Load here. So this is the 8760 data set describing the building's energy consumption. So we can see that it's got a big summer peak here at about a little under 4.5 kilowatt hours per hour. We can zoom in to see what the daily load shape looks like, and we can look at the data in other types of graphs. Here's a heat map. It's kind of a nifty way to look at the whole data set. We can see that the peak is shifted from noon. It's toward after between 4 and 10 p.m. here in the summer hours, presumably an air conditioning load. So this is the hourly data that SAM needs, which again is hard to come by for real analysis. We've got a couple of tools to help you enter this, to work with load data that you're more likely to have, which is a monthly utility bill. Often that's all you have is the residential consumer's monthly kilowatt hour consumption. So what we have is an option that we call Normalized Supplied Load Profile to Monthly Utility Bill Data. So what that means is we take this hourly load profile and we just scale. We take each month and we scale it up and down to some monthly kilowatt hour value that you specify. So if we check this box, then we check Edit Values. Here's our monthly utility data, right? So we put 250 kilowatt hours, for example. I'm just making up numbers here. Probably don't make any sense, but just so you can see what happens. So you'd put in your monthly load, monthly electric consumption for each month, and then click OK. And that changes now the monthly totals and the monthly peak are scaled to the values that I entered in that table. And if we look at the graph now, we can see that the blocks of the hourly data are bumped up and down to match the normalized values that I entered. Okay, so that's sort of a quick and dirty way that we've set up here for you to work with electric load, with monthly electric load data that you're more likely to have than hourly. I'll talk a little bit more later about some improvements over this approach, and also we are working on a new sort of load profile generating tool that will be part of future version of SAM, so that's something to look forward to. It's not available in the current version, unfortunately. All right, so that's our load data. I'm just going to go with the default load data here, and now we'll move to the utility rate page, and this is where we specify the electricity rates. So this is a really busy input page. Hopefully by the end of the hour you'll be comfortable enough with it to start working with it. So I said I was going to do a basic flat rate structure with a flat buy rate of 9 cents per kilowatt hour and a flat sell rate of 6 cents per kilowatt hour. Okay, so what I'm trying to model here is a project where in any given hour, if the system is producing more energy than the household is consuming, that electricity will be sold to the grid at 6 cents per kilowatt hour. And for any hour where the load is greater than the kilowatt hours produced by this renewable energy system, we're buying that chunk of electricity at 9 cents per kilowatt hour. I'm going to say there's no fixed charge. The only feature of this rate structure is that flat buy and sell rate. So I want to disable all the other inputs, which I can disable this entire block of inputs by clearing that checkbox. And again, do the same thing down here. Okay, and now I'm ready to go. So I'll click Run. And I'm working on a low resolution screen here so you can see it better, but that means I have to resize things here as we're working. So I run the simulations and I get this, my sort of high-level results show up here in the metrics table in the lower left corner of the screen. And I have a slide here that I'd like to show to describe what these metrics are. So here's our metrics table. And the metrics of interest for this particular discussion are these three here. So the electricity cost without system, with system, and then the net savings. So the cost without system, this is our total annual electricity bill if we didn't have the renewable energy system. And then the cost with system, that's our total electric bill with the renewable energy system. So it should be less than the cost without system because we're having to buy less electricity from the electric utility. This cost doesn't give us any information about the installation, the cost of the renewable energy system. The metrics like the net present value and payback period give you information that account for the cost of the renewable energy system. The net savings here is just A minus B. So cost of electricity without the system minus the cost with the system is how much we save on an annual basis. Okay, let's jump back to SAM. Okay, now one thing you'll notice about the metrics in my example here is so we save $500 per year by installing the renewable energy system, but we have a net present value, a negative net present value, and so generally we want to try to have a positive net present value. So if I were analyzing a system, I would want to refine my inputs here to try to see what's going on with why we're getting a negative net present value. One technique that we can use to do this is parametric analysis. So I'm gonna zip through this pretty quickly. You can come back and look at the recording to see, follow through my steps if you want. There's also other resources on the learning page that talk more about parametric analysis. But here I go. So I'm going to click Configure Simulations, this button next to the Run button. And I'm going to do a parametric analysis. And what I want to do is run SAM for a range of cell rates. So instead of just having a single cell rate of 6 cents per kilowatt hour, I want a range of flat cell rates. And I'm going to look at from 2 cents per kilowatt hour, 02, to 10 cents per kilowatt hour, increments of 2 cents, update. Okay, so there's the range of cell rates that I'm gonna look at, from 2 cents to 10 cents per kilowatt hour. Click Run. Sam ran a simulation for each of those cell rates, and now I can create a cool graph that shows, I'm going to run, this is for a parametric analysis, so I'm going to change this to parametric. And I want to plot a graph. I want the flat cell rate to be on the x-axis. So I'll just choose flat cell rate. And let's look at net present value and payback period. And we can get rid of some of these, change these labels to make more sense. So Y1 is a dollar value, Y2 is years. There's my graph as I do it. I think a line's going to be clearer here. Let's add a legend. Okay. And then I've got two graphs showing here. I just want to look at one graph. So if I click the thumbnail down here, that's going to make one graph appear. And then now we have a graph showing net present value in blue and payback period in purple. As the flat cell rate increases, we can see where the net present value turns positive. So we need a cell rate between 7 and 8 cents per kilowatt hour to have a positive net present value, and then the payback period, decreases, goes down as we increase the cell rate. Okay, so that's an example of a basic rate structure and a quick tutorial on a parametric analysis, which you may find useful. All right, let's go back to Mr. PowerPoint here. Okay, the utility rate input page has a whole bunch of terms, and I want to spend a couple minutes talking about what those mean. So we've got energy rates, we've got demand charges and fixed charges. So an energy rate is a price per unit of electricity. It could be a price paid by the project or a price received by the project. A demand charge is a price per peak consumption over a given period, so it's $1 per kilowatt value. And then a fixed charge is just a fixed dollar amount that applies per month. We've got time of use rates and charges. So these are rates and charges that vary with time. So you may pay a higher energy rate during summer peak periods, for example, in an area with high air conditioning loads. You may pay higher rates in the mid-afternoon, for example, and lower rates in the morning and night. There are tiered rates and charges. So these are rates that vary with electricity consumption. So that might mean that you pay one rate for anything up to some number of kilowatt hours per month that you consume. For example, here in Portland, I pay one rate for anything that I consume up to 1,000 kilowatt hours per month. And then anything that I consume above that amount, I pay a second higher rate. So that's to encourage people to use less electricity. And then there's a fixed rate or flat rate. That's what we just looked at. That's a rate that doesn't vary with time or consumption. And then in SAM we have buy and sell rates. So buy rate, these are from the perspective of the home or building owner. So the buy rate is the price paid by the consumer for the electricity delivered by the utility, and the sell rate is the price paid by the utility to the consumer for the electricity delivered to the grid by the consumer. All right, here's a question. How reliable, frequently updated are the rates in OpenEI? We'll get to OpenEI in just a moment. Thanks for that question. Sell rate is for hourly excess generation. Yes, if you're not modeling, if you don't have net metering turned on, then the sell rate is for hourly excess generation. We're going to look at net metering next, and that's a scenario where the sell rate is not, well, where there is no sell rate, I guess. So yes, the answer to your question is the sell rate is for hourly excess generation. All right, net metering, I could probably spend the entire webinar, if not several days, talking about net metering. I'm going to spend about 30 seconds. But I just want to make sure that we get a basic definition here, and we can talk about it more during Q&A if you've got questions. So net metering is an arrangement between the electric service provider or the electric utility and the consumer that allows the consumer to offset purchases of electricity using electricity generated by the renewable energy system. And the terms of this arrangement are determined by net metering laws, which vary by jurisdiction. So I think in the U.S., typically states make the law, and then they're implemented by utilities in various ways. So there's lots of different approaches to net metering and lots of little details about how net metering happens in real life. In SAM, the net metering, this is how the net metering option works. The system owner can purchase electricity at either a fixed or tiered or time of use buy rate, and then receives a monthly credit for each month that the electricity generated by the system is greater than the load. So the comparison is done on a monthly basis based on monthly totals. And then the credit that you earn in a current month applies to the next month's electricity bill. And then at the end of the year, there's a year-end sell rate, which can be different than the buy rate. So let's have a look at how net metering works in SAM. And what I'm going to do here is create a net metering case that's identical to our flat rate case, so that we can do a comparison. So let me rename this case. I'll call it flat rate. Whoops. So that was on the case menu rename, and then case duplicate. So I'm going to make a copy of this case, and then case rename, and I'll call it net metering. Okay, and I don't need my parametric analysis for this net metering case, so I'm going to disable it. And so we have our same 4 kilowatt PV system, and I'm going to use the same load, but this time I'm going to enable net metering. Okay, so you'll notice when I enable net metering, the flat sell rate goes gray. If you're using a Mac, when things go gray, it's kind of hard to tell. Just a quick note there. But that means the sell rate doesn't apply for net metering. And the year-end sell rate is active now. So I'm going to keep the buy rate at 9 cents per kilowatt hour. I'll change this sell rate to 3 cents per kilowatt hour. And then let's run this thing and see what happens. Okay, so to look at what's happening with net metering, I want to look at monthly, some monthly data here. So I just clicked Add New Graph, and I want a monthly graph. And what I'm going to look at kilowatt hours first. So this is monthly energy, is the energy generated by the system. Let's also look at the load, kilowatt hours, and the net metering credit in kilowatt hours. So we'll get rid of that title because it doesn't apply. Change the label to kilowatt hours for the y-axis. Let's see, bar graph is good, and let's show the legend. Okay, and then I want to make this graph bigger, so I'll click its thumbnail down here. Okay, so in gray is the load. In dark blue is monthly energy. In light blue, which we don't see anywhere, is net metering. So in this case, the load is, every month the load is greater than the energy produced by the renewable energy system, so we get no net metering credits. Well, let's see. It looks like during the summer month or the winter months, our energy production is fairly close, or at least closer to the load than it is during the summer months. So maybe if we bump up the size of the system, we can get some net metering credits. So I'm just going to increase my my PV system's DC capacity. Of course, that's going to increase the installed cost and so on. We'll just do it for now. So 6 kilowatt system. My graph that I created is still there, so I can look at it again. And now we see we have net metering credits in March, April, and May. So in February, we produce almost exactly the amount of energy that we consume. In March, we produce more. So we get a net metering credit that's going to be rolled into April. And April, we've got excess production and maybe a little bit of leftover credits here, because the height of this bar looks taller than the difference here. Anyway, so these credits are being rolled over into the following month. And then if we had had credits in December, those would have been valued at the year-end sell rate. Okay. Just a comment there about Mac. No questions. All right, let's go back to the presentation. All right, now let's talk about the utility rate database. For rate structures that are more complicated than the ones I've been demonstrating here, you can either, enter the get the rate sheet and figure out how to enter the data into SAM by hand, or you can use the download feature to download the rate data from this database that's hosted on the NREL OpenEI platform. Let me just bring that over here for a second. This is the OpenEI website, and this is the page for the utility rate database. So SAM is communicating with the underlying data that's being displayed on this website when you use the download feature in SAM. Sorry, here I got too many things going on. So for those of you who've been using SAM for a while, we shifted over to a new version of the URDB. So the URDB on OpenEI was updated from version 1 to version 2, and there was a data structure change involved with that update, and so we had to change SAM to match that. So older versions of SAM worked with version 1. That version is no longer being maintained, so if you're running older versions of SAM, you may not be able to download rate structure data. So we always recommend that you work with the current version of SAM. This is one reason why. The version 2 of URDB at the moment has rates for 3,831 electric utilities. This data is only available for the United States. It's a U.S. database. Unfortunately, we don't have data for other countries. And let's see how it works to download the data in SAM. So let's create a new file here. And again, I have an example of that. The file that I just closed will be on the website if you want to look at it later. And we go to utility rate page, and to download data, you click the search for rates button. If you click this button, this takes you to the OpenEI website, so you don't have to worry about remembering what that link was. Click search for rates. SAM takes a minute to establish a connection with the database, and then here's a list of all the utilities for which there is data. And then you can filter the list. So I'm based in Portland, Oregon, so let's look and see what there is for my utility. Portland General Electric. So I click the utility name here, and then it gives me a list of all the rates that are available for that utility. I've got this list filtered by residential only. If I want to see all the schedule available, they're here. So we can look at residential, commercial, and let's see, my rate is residential 7. So I click that rate, and then I can go to the page for that rate structure on OpenEI by clicking the link there. And then this has a link to the rate sheet from the utility. So you can get to the rate sheet that way. And then when I'm ready, I click download and apply utility rate. And then now the inputs on this page are populated with data from the URDB. Okay, so that's how it works mechanically. I've got some screenshots that you can refer to later to go see and see what those steps are. Some tips here. After you download the data, be sure to look through the inputs on the utility rate page and make sure that what's in SAM is consistent with the rate sheet. I highly recommend that you get a copy of the rate sheet and don't just rely on the data from the database. As you saw, there's a lot of data in that database, and it's possible that there are errors. And it's also very likely that the rate structure has changed since it was added to the database. Things are constantly in flux. So check and make sure that the data is consistent with what you intend to model. Another point here is that oftentimes the rate sheet will show several different energy rates, for example. They might have line items for different rates, and in SAM that will just be represented by a single energy charge number. So be aware of that. And then we've tried to make the inputs on that utility rate page flexible enough to represent as many different rate structures as possible, but there may be some details of some rate structures that aren't exactly replicable. And then if you do notice problems with the database, you can let the folks at OpenEI know by going to the community page on their website. Let's see. Sorry about this. So if you go to community here, you can provide feedback about the database. You can also contact me about it, but I'm not directly involved with the database, so I'll just refer you to someone who is. Let's see. Okay, let's see. There's a question here. A couple of them. With respect to utility rates, I would suggest checking accuracy of downloaded data with actual utility tariffs. Absolutely. Thanks, Mike, for that comment. And then we still need to manually specify whether or not the rate is TOU or tiered, et cetera. So that's a good question. These checkboxes should be enabled or disabled based. That information is in the database, but it's again up to you to go through and check and make sure that things are enabled and disabled as appropriate. Like in this case, enabled demand charges is checked, but there are no demand charges, so it's effectively unchecked. Let's see. If NEM has a time limit, like the new 20-year limit approved by the CPUC in California, can you account for that in utility rate module? No. If you've got a 30-year project and there's a utility rate that only applies for 20 of those 30 years, I think that's what you're describing, there's not a way to model that in SAM. The rate structure applies to every year of the analysis period. Can you build rates that are both tiered and TOU? Yes. I'll try to show you that in just a second. Make sure I covered everything here. Yeah, so the next thing I want to do is just show you some of the mechanics of the various inputs here. Oh, I don't need a reminder. I'm doing that now. Thank you. Okay, so we've got fixed rates. We already looked at flat buy rates. We looked at net metering. Monthly charge, fairly self-explanatory. It's a fixed dollar amount that applies to every month. Annual escalation is a way to make the rates escalate uniformly from year to year. So that's a possibility here. You can read more about it in help if you want to see how that works. It's probably not a commonly used input. But so here's time of use and tiered energy rates. So yes, rate structure can have both tiers and time of use. So periods 1 through 12 here these are the time of use periods, and you can have up to 12 of them. And the way you specify, I mean, this particular rate structure has one period. So this is period 1. Everything here is ones. If we want to make this apply a time of use period for period 2, let's say there's a summer peak period that looks like that. So it's from noon to 5 p.m. in June, July, and August. We'll call that period 2, and then you can put the TOU rate for period 2 in the period 2 box, and that block can also be tiered. So the mechanics for this are I'm using my mouse here. I click on a square and then drag it to draw my block, and then I type a number on the keyboard. So I type the number 5, and then you might be wondering, well, how do I get number 10 in there? Well, it turns out that 10 is A, and 11 is B. Okay, so you can poke around to help to find that, but I'll show you how that's done. And then we have a similar setup here for demand charges. So you can have tiered demand charges and time of use or tiered demand charges, and you use the same mechanics for that. Is the max usage in the period tier an incremental or cumulative value? I'm going to get to that in just a second. So the way the max usage number here works depends on whether net metering is enabled or not. So if net metering is enabled, then these tiers accumulate monthly. If net metering is not enabled, then these tiers are hourly tiers, which is an unusual way to do tiers, but that's the way it works in SAM at the moment. And I have a nice little slide to demonstrate that here. Okay, so if you're working without net metering, then these tiers are not cumulative. They're hourly. The maximum kilowatt hours is an hourly peak. Whoops, sorry. So if you have no net metering and you modeled tier 1, a tier structure that looked like this, assuming that it was monthly tiers, you would never exceed the level 1 tier, because in this particular case the usage never goes above 4.5 kilowatt hours per hour. Okay, so that's an important little detail. We're looking to redo that if it makes sense, so that the tiers are accumulated monthly, both with and without net metering. All right, I want to make sure we have some time for questions. So I'll do a quick little talk about the value of PV. So this is a method that's described in a few different NREL reports. I think the most recent one is, I've got a reference for down here. And this is, SAM was used for this analysis. So we define the value of PV in this particular case as the value of the electricity generated by the PV system, and it's the savings, the annual savings divided by the annual generation from the PV system. And then, so when you're doing this kind of analysis, you're comparing a, you want to look at a rate structure that applies when you have a PV system and a different rate structure that you have with no PV system, because the value of PV described in these reports is a net value of PV analysis, which means that they're comparing the lowest cost rate structure for the without system case with the lowest available rate structure for the with PV system. In SAM, when you set up this utility rate, there's only one utility rate structure. So the with and without case, let me, I'm just going to open a file that makes a little more sense. This sample file, residential net metering and tiered TOU example, is a good place to go to get started with these rate structures. This sample file has notes explaining all the inputs, so it's a good learning tool. But to get back to my point, in this particular case, we have net metering, for example. The net savings here are based on the same rate structure. So the cost without system and the cost with system both use this same net metering scenario. For a tiered time of use scenario, it might be that you would use the tiered time of use structure with the PV system, but without the PV system, maybe it would just be a flat rate, for example. So you can't do that in SAM without using a SAMUL script. And I'm going to show you, to finish up here, I'm going to show you those scripts and run a couple of examples so you can see how they work. So there's two SAMUL scripts here that are that I think you'll find useful. One is so it's under sample file here on the file menu, and download building load data. So when we were talking about load data before, I said that I'd show you some tools that we have to make your life a little bit easier when you're trying to find hourly load data. And this sample file has a SAMUL script. So a SAMUL script is something like VBA in Excel. It's a little program that you can write to set the value of inputs and run simulations and read values of results. And we've written the script for you here that downloads data from another OpenEI database it's a database of load data. It's modeled load data for sort of a set of typical commercial and residential buildings based on the some DOE building programs. So this data is available on the OpenEI website, and you can use this sample script in SAM to download the load data from that database. And all you need to do is run the script. So you run the script, and it says, okay, is it a residential or commercial building? Say it's a residential building. And then is it a base building or a high load scenario or low load scenario? We'll say it's base. And then it waits for a minute, and then it says, hey, I downloaded it. So now if you go back to the case and go to the load page, this is the load data, hourly load data from the database. And if it looks similar to the default data we've been looking at, that's because that's where that came from. What the script does is it goes to the weather file here to find out where you are. So this is in Arizona, and then it finds the load data for the building type that you specified for that location. So you have to have a TMY3 weather file loaded up here. This is all explained in the notes. So that's one handy dandy script that we have for you, and we've got this in a sample file. But if you want to use the script in your own file, you can save the script. So let's save it as download load data .sul. That's just a Samuel script file. Okay, let's save it there, and we'll come back to it in a moment. I'm going to show you another sample script that allows you to do the PV or the savings calculation. It doesn't have to be PV with two different rate structures. So this is a sample file with a Samuel script in it, and our base. So the way this script works is you set up your base case to be your PV system, or the renewable energy system. So it's a PV system in Phoenix, and here's the load. And then when you run the script, first it says you have to save the file before you can run it. So let me do that. Okay, then I'll run it again. Okay, so first it asks me whether the case in my file is for my renewable energy system. It's just confirming that I've set up all the inputs for the renewable energy system. So this is going to give me the savings with system. So I'll answer yes. And then now it's asking me questions about the without system rate structure. So the rate structure for the with system is specified in the case. The without system rate structure, let's say that it is a flat rate. So I'll click yes, and I'll say that the flat rate is 9 cents per kilowatt hour. And then it asks me about a year-end sell rate. No, I'm not going to worry about that. And is there a fixed monthly charge? Let's say there's a $10 fixed monthly charge. And then it gives me the cost with the system, cost without the system, and the savings. So this time, I've compared the with system is a tiered TOU rate structure with the renewable energy system, and then my base case without the system. So this is just the home paying flat rates is using a different rate structure. And then if you want, you can save this to a text file and then use the data in your analysis. And this is a script that you can modify, so you can make it work in different ways if you like. So this, you'll notice that if we go to that text file, let's see, just dig it up here for. So here's the text file. You'll see that this is just showing me the information that was in that window that popped up, and we've got cost with and without system and first-year savings. These are the same numbers that you see in the metrics table. The script also calculates that energy value, using the methodology described in the NREL report that I described. Okay, so we've got a couple of sample scripts that we hope will make your life a little bit easier. So that's what I had today. Let me conclude quickly, and then we can do some Q&A. So to model a residential and commercial system in SAM, a distributed energy system, you need information to describe the renewable energy system, your financial assumptions, you need cost data, you also need load data and utility rate data. So you need a bunch of inputs to run the model. The utility rate page is flexible, and it's designed to represent a lot of different rate structures. It also means that it's a little bit complicated, unfortunately. But it does interface with the OpenEI database so that you can download rate data for the US. And then we've got a couple of SAMUL scripts to help overcome two of the limitations of the SAM model. One of which is that the with and without system is, by default, calculated using the same rate structure. And the other is that it's hard to find load data. So that's the end of my talk. I see a few questions here. Could you use SAMUL to iterate your simulation over several sets of hourly load data and export results? Yes. Yeah, SAMUL is actually pretty powerful. You can do all sorts of things, but it's one of its main purposes is for running simulations where you want to do lots of repetitive runs. Does the script only display the year one savings? The script, if I recall, is only displaying the year one savings, but you could modify it to calculate the savings in a different way if you wanted. For example, I think the instructions in the script actually mention that you could use NPV instead of the year one savings. Is there a description of the scripting language available? There is. As always in SAM, you press F1 in Windows or Command ? To see its beautiful help system that I wrote. And there's a whole section on SAMUL. If you go to the SAM website and search the SAM website, you'll also find examples in questions about SAMUL, people having issues with some of the functions, and some sample scripts as well. So the help system and the SAM support forum are both sources of information about SAMUL. Okay. Here's one that I don't think everyone else can see. Are there any plans to include storage solutions in the system? So at the moment, only the concentrating solar power systems have storage components, and that's a thermal storage component. I guess the solar water heating system has water heating, a water tank. But what people are really asking us a lot about these days is whether we're going to add storage batteries to the PV model. And the answer is, we hear you. Keep telling us about it, and we'll see what we can do. We don't have any immediate plans to add storage to the PV model, but it's something that could come in the future. If you've got any other questions, please let me know. I'm gonna unmute the folks over at NREL in case Nate and also Sean. I will unmute Sean in case you guys have anything to add. So the floor is open to you guys, Sean and Nate. Any other questions?
Can you hear me now?
Yes, go ahead, Nate.
Okay. I think we're going through the computer rather than the phone, but I would just add that we're working on future plans for SAM, and a number of requests have come in both from the industry and from the research community as PV battery storage becomes something that a lot of people are interested in looking at. So we hope to be able to add that to our development list for next year.
Hey, and this is Sean. I just wanted to reiterate to everyone how powerful SAMUL is as a scripting language. That, as a pretty good user of SAMUL, you've only seen the surface with being able to download load data, being able to download rates through the scripting language, going through all these buildings and iterating. So if you use SAM at all and you're a scripter, it's really worth checking out.
Not seeing utility rate on SAM for Mac. That one, please email me using the contact form on the SAM website. That's a problem if there's if you're not seeing utility rate page on the Mac. Can SAMUL be used to add battery capabilities? No. So this is a good question that we get often. I'll just touch on it, even though it's a little off topic. SAMUL is the scripting language. We also have an SDK, a software development kit that allows you to do sort of build your own models using pieces of SAM. You can't really add new components to SAM using either of these tools. Basically, what the tools do is allow you to set the value of inputs, control simulations, and then read the value of results. They don't really allow you to add to the modeling capability. Okay, we're about 5 minutes over. I can stick around for another minute or two in case there's any other questions. All right. Well, thank you all for your participation. Again, a recording of this session along with supporting materials will be available on the learning page of the SAM website. Oh, we got a question. Let's just take it real quick. For electric load, can you enter actual energy use and actual peak demand for analysis? I think if I understand your question, the answer is yes. If you go to the electric load page and click, and let's see, we'll choose user entered hourly data and click edit data. If you've got minute by minute data, 10-minute data, 15-minute data, you can enter it here. If you've got it formatted in a text file in a single column, you can just import it. And then because SAM is an hourly model, it will convert that data into hourly data, but it'll extract the peak values for the peak data. And it looks like there's a question above that I missed. And yeah, I mean, for this regarding the SAMUL script and the year one savings, you can display any of the output. You can manipulate any of the output variables and calculate metrics based on them. So if you want to look at savings over the entire project life, that's possible. Okay, I will sign off now. I think we're over by 10 minutes. Thanks you all for your participation. If you've got more questions, please feel free to post them on the SAM support website, SAM support forum on the SAM website. I can answer them there, and we can carry on the conversation. And look forward to hearing from you all soon. Thanks again, and I will be signing off.